Hi guys, this is Dr. Turner for Integrated Math 3. Today we're talking about 2.4, which is graphing polynomial functions. As I mentioned in 2.3 when we talked about graphing cubic functions, really our goal here is we're looking for just the basics of graph, key features, what's this graph going to look like. We're not looking to do a perfect polynomial function here, but we want to talk about the characteristics, and we'll get a little more advanced graphing of polynomial functions after we've covered a few units later in the year. For right now, what we want to do is to be able to identify, again, key features and talk about zeros, extrema, things of that nature. But first, we're going to take a step back and revisit a topic we've seen in Integrated Math 1, Integrated Math 2, which is we're talking about polynomials. Well, how do you classify polynomials? There's a few ways you can classify polynomials. The first is by what's known as degree or rank. The second is by the number of terms. When you're looking at the number of terms, you're looking at an expression and saying, how many terms are there? And terms being separated by plus or minus signs. They are a product of coefficients and variables. So for instance, if I had something like 4x squared minus 7x plus 10, looking at the things, quote unquote, that are separated by plus or minus signs, I have 1, 2, 3. So that would be a trinomial. If you have a single term, that is a monomial. If you have two terms, that's a binomial. 3 terms, trinomial, and any more than that, we kind of stop counting. You could technically name them, but most textbooks don't. So after that, we're classifying the polynomials by their degree or rank. And what a degree is if you're looking at all the terms, you're looking for the highest exponent. So if your highest exponent is none, there's no exponent there, then we call that a constant. If you're looking at a function that has just an x with no exponent, that is a linear polynomial. If you have the highest power is squared, then it's quadratic. Third power is cubic, fourth power is quartic, fifth power is quintic, so on and so forth. You should be familiar with quadratic and cubic because we're talking about those specific properties here. While there are other terms for x to the 6th power, x to the 10th power, they're less common. What we do generally after the third power is that we'll just refer to the number or the numerical degree. So we'll say if it's x to the 4th, we'll say it's a 4th degree polynomial. If it's x to the 5th, we'll say it's a 5th degree polynomial, so on and so forth. So looking at these polynomials, the first key feature that we want to be able to identify is where the graph is rising, where the graph is falling. And this is what's known as a leading coefficient test. If we're in person, we'd go into a little more detail with how this looks, but for right now, this is basically your leading coefficient test. So if you have even degree polynomial like x squared, and you have a leading coefficient that is positive, like 1 here, from the origin or from the center, it is both rising to the left and rising to the right. If you have an odd function, like x cubed, then it is falling to the left and rising to the right. And just as we mentioned in 2.3, when I have a negative leading coefficient, right, it's going to flip the graph upside down, which means that for an even function, if my exponent is even and my leading coefficient is negative, then it's going to be falling to the left and falling to the right. And if I have an odd function, then and a negative leading coefficient, then it's going to be rising to the left and falling to the right. Those are one of the key features we want to be familiar with. Another, and let's here. So the other type of key feature we'll be familiar with higher level polynomial functions is are what are known as your relative extrema. So your relative extrema are extreme points. So extrema is plural extremum, and basically we're categorizing minimum and maximum points in a single category. If you have a function like a cubic function, there's technically no minimum or maximum here because the graph continues to go up and down in both directions as we zoom out here. But here, we kind of have a maximum point and we kind of have a minimum point. And so we call those relative maximums or minimums or relative extrema. So one thing you're asked to do in this section is identify relative extrema. So you would tell me the relative extrema of this cubic function are -4, 32, which is a relative maximum, and 0, 0, which is a relative minimum. Also important to note that the number of extrema is going to be limited to the degree. The maximum number of extrema points is going to be 1 less than the degree. So because this is a cubic function, the most that I can have, and that's a key word there, the most that I can have is 1 less than 3, which would be 2. It won't always be that case. For instance, let's look at the quadratic function, x squared minus 1, or minus 5. Zoom in here a little bit. Okay. So here, the quadratic function can have a maximum of 1 extrema. And so in this case, because my leading coefficient is positive, that extrema is 0, -4, which is a minimum. Because the graph doesn't go below that point, this would be an absolute minimum or an absolute extrema. And vice versa, if I have something like negative x squared plus 3, same thing, I can have 1 extrema because it's 1 less than 2. And here, my extrema happens to be a relative or absolute maximum at 0, 3. As another example here, we have x to the 4th plus x cubed minus x squared minus x plus 1. Because that's a 4th degree polynomial, the most maximum or minimum points that we can have is 3. So 4th degree has a maximum of 3 extrema. So identifying these points here, and Desmos will be kind enough usually to label those as points because that's what we're looking for in this assignment. And so these would be your values. Because we're trying to keep this straightforward, most of the time you're going to have extrema points that are integers, but just because it's a decimal doesn't mean it's wrong. A lot of students make that mistake, and just because we're talking about 4th, 5th, 6th degree polynomials, you're probably going to get examples where you don't have an integer. So just be mindful of that. So we said that the number of extrema is going to be 1 less at most, 1 less than the degree of the polynomial. So similarly, if I gave you a function like this, and I see that there are 1, 2, 3 extrema, then you should be able to tell me that 1 higher than that, this should be a 4th degree or quartic polynomial. As we mentioned with cubic functions, there are going to be other techniques that we'll use to identify the zeros of a higher degree polynomial. For now, because our focus is on graphing, you're welcome to use Desmos to identify when it asks you for the zeros. So let's say I have a 4th degree polynomial, I type it in and this is the graph it gives me. Then to identify the zeros, we would simply look at where the graph is crossing the x-axis. So I would say the zeros of this function are -3, 0, -2, 0, -1, 0, and 1, 0. Be careful with this. When we were talking about extrema, we said that you can have you can only have 1 less than the degree. With zeros, you can have at most however many there are for that degree. So for instance, if this is a 4th degree polynomial, you can have up to 4 zeros. That's not always the case. Again, it's up to. So for instance, if I have, let's say, x squared minus 1, for instance, this is a quadratic, it's a 2nd degree, and I have 2 zeros. But that's at most. If I made this x squared, then there's only a single point where it's crossing the x-axis. So it only has 1 0. And if it, for some reason, it's above the x-axis, then there are no zeros. So the number of zeros is going to be equal or less than the degree of the polynomial. All right, guys, that's it for today. I know it was brief. If you need to, go back and review some of the old videos from Math 1, Math 2. If you have any questions, reach out to me, but otherwise, have a good day, and I'll talk to you soon. Bye.